Lesson 2.5, Solving Equations Using Addition and Subtraction. Inverse operations. Inverse operations are two operations that undo each other. It is important to remember that they undo each other. So, for example, addition and subtraction. They're opposite operations or inverse operations. Just like multiplication and division. Equivalent equations have the same solution. Equivalent means equal, so they're equations that are equal to each other or have the same solution. Let's talk about how to isolate the variable. To solve an equation, we try to isolate a variable on one side of the equation. To accomplish this, we use inverse operations to cancel terms and coefficients that are on the same side of the equation with the variable. Remember, isolate means to get it by itself. So we're trying to get the variable by itself on the one side of the equation. Remember, the equation is split up by the equal sign. Let's talk further about that. How does it work? There are two sides to an equation. The equal sign separates the two sides, the left from the right side. You have 4x plus 9. To undo or move the plus 9, which is positive 9, to the other side of the equation from the left to the right, we use the inverse operation. So instead of adding, we subtract 9. What happens there is that makes 0. That's called inverse operations. There's the minus 9. There's the minus 9. What this is called is balancing the equation. Because we subtracted 9 from the left side of the equation, we have to do the exact same thing to the right side of the equation. We always have to keep our equations balanced. Now what happens is that there is no more 9 on the left side. All we have to do is bring down the 4x. And then 41 minus 9 is 32. Next thing that happens is we need to get rid of the 4. Remember, the whole goal is to get the variable by itself, or to isolate the variable. So 4 times x, the inverse operation, would be to divide. And we divide by 4 on both sides because we have to balance the equation. 4 divided by 4 leaves 1x. Remember that 1 times x just equals x. You don't need that 1 in front. And then 32 divided by 4 equals 8. So x equals 8. Subtraction property of equality. Subtracting the same number from each side of an equation produces an equivalent equation. You have x plus 3 equals 5. So I can subtract 3 from both sides of the equation, and that's going to get you an equivalent equation. They like to do things horizontally. I'm going to show you how to set it up vertically. So here's the problem, x plus 3 equals 5. You can see that we are adding 3, so we need to subtract 3. I also am going to slightly change how they say things, because we know that subtraction is actually just adding the opposite. So what you can think of is, because we are adding a positive 3 to the x, let's add a negative 3 to this side of the equation. Okay, remember there's two sides, left and right side. And because I added a negative 3 to the left side, I also have to add a negative 3 to the right side. And what is 5 plus negative 3? Different signs, we subtract, you end up with 2. 5 is larger, so we leave it positive. Bring down the variable x, and you can see x equals 2. You can always go back and check your work. X plus 3 equals 5. We just found that x is 2, so let's plug that in for x. What is 2 plus 3? That is 5, so it checks out. And here's the algebra just telling you that you can subtract a number from both sides to produce an equivalent equation. Remember, instead of subtracting, I'm going to say add the opposite. Add the opposite. Example 1. X plus 5 equals negative 2. Here's the positive 5 on the left side of the equation. How do I get rid of the positive 5 so I can leave x by itself? The whole goal is to get x by itself. We need to add the opposite of 5, which is negative 5. And again, I do the same thing on the right side, which is adding a negative 5. What happens on the left side, is that these positive 5 plus negative 5 cross out. That makes 0. So you're just left with x. And then negative 2 plus negative 5, two negatives, just add 5, 6, 7, and then keep the negative sign. Negative 7 is your answer. You can go back and check by putting negative 7, and actually do it below. The solution is negative 7. Put negative 7 in for x. Does negative 7 plus 5, does it equal negative 2? Well, 7 minus 5 is 2. 7 is a bigger number, so you use the negative. It does, so it checks out. Again, let me just quickly show you how it works when you want to do it vertically. Add a negative 5, add negative 5. This becomes 0. Bring down the x. Bring down the equal sign. The equal sign always kind of stays in the line, and that's negative 7. The addition property of equality says that you can add the same number to each side of an equation to produce an equivalent equation. So x minus 3 equals 5. We can add, this was minus 3, so we can add 3 to both sides to produce an equivalent equation. Again, let me show it to you more vertically. Split up the sides. I always put that line so I can see the two sides. Okay, I'm going to change the subtraction right away. Keep it the same, x is the same, add the opposite. So this is now negative 3. So now I add a positive 3. So we are always going to add the opposite. Change all subtraction and then add the opposite to produce an equivalent equation. This is 0, we're left with x. Now because we did add 3 on the left side, we also need to do that on the right side. 5 plus 3 is 8, x equals 8. And again, you can check 8 minus 3, that is 5, so it checks out. And here's the algebra that tells you that you can do that for any problem where you are subtracting a number from a variable. Example 2. 12 equals y minus 7. Okay, the first thing I'm going to do is change the subtraction to adding a negative. Again, the more you keep changing subtraction to adding the opposite, not just negative, add the opposite, the better you're going to be able to look at these problems, because that's not a positive 7 up here. That is a negative 7. So how do I move the negative 7? I know this is on different sides. Okay, so instead, I want to leave the variable on the right side. That's where it starts, that's where it's going to end. And we're going to move things over to the left side. So how do I move this negative 7? Let's change that to negative 7 as well, adding negative 7. Well, the opposite of negative 7, or the inverse operation, is adding positive 7 to both sides. Negative 7 plus 7 equals 0. So that will cancel out. You're left with y. 12 plus 7 is 19. The solution is 19. And again, you can check your work. 19 minus 7 is 12, so it checks. Number 1, 2, and 3 solve the equation. Remember, add the opposite of the number to each side. So there's two sides to a problem, left and right. Get the variable by itself by adding the opposite of the number that's being added to the variable. Pause the video at this time. Problem number 1. This is x plus 6. Okay, remember we are always starting with the side that has the variable. The whole goal is to get the variable by itself. So this is the side we're going to start on. This is adding 6, so I'm going to add the opposite, which is negative 6, to both sides. Okay, remember this is balancing your equation right here. Same thing on both sides. Well, 6 plus negative 6 is just 0, so they just cancel each other out. 19 plus negative 6, well, this is just subtracting because they're different signs. 9 minus 6 is 3. Bring down the 1. You have 13. 19 is a larger number, larger absolute value. It is positive. Your answer is x equals 13. This is 13. Number 2. Two sides to the problem. Find the variable. The variable this time is on the right side. This is where we're going to start because I'm going to end up with the variable on the right. We're isolating that variable on the right. That means we need to move the adding 12. Let's add the opposite, which is negative 12, to both sides. On the right side, those 12s will cancel out because one's positive, one's negative. That makes 0. Negative 5 plus negative 12, just to add, keep that same sign, your answer is negative 17 equals y. Again, you can always check by putting it in for y. Negative 17 plus 12, subtract. Bigger sign is negative, so it's negative 5. That checks. Number 3, there's the equal sign. Let's put a line. Here's the variable, so we're going to start on this side. Let's change subtraction to adding the opposite. And now to get m by itself, I'm going to add the inverse, or the opposite, of negative 3, which is positive 3, to both sides. Okay, balance those equations, both sides. This becomes 0. And negative 11 plus 3, we subtract 8. And it's negative because 11 is bigger. There is your answer for 1, 2, and 3.